Hi, guys. Today we're going to be talking about the density of the layers inside of the Earth. So the first thing you need to do is watch this video and take these notes. Now, I've included them here in the video, but also I've included the PowerPoint just with this Google Classroom assignment. And you can go through and find the slides you need to if I'm going too fast, or you can just pause the video to get the stuff written down that you need. So yesterday in class, we were talking about how we know what the inside of the Earth is like. I showed you how we did these earthquake waves that travel through the Earth. And based on those earthquake waves, we are able to extrapolate a lot of information about what it's like inside the Earth. Now, one thing that we're going to talk about is the density of the material that's inside the Earth in those layers. Now, if you remember back to when we were talking about density way back at the beginning of the year, I showed you this picture. And what we see here are these liquids and these, point this way, these liquids and these solid objects that are separated out based on how dense they are or how heavy they are for their size. Now, in this column here, we see that the heaviest object, which is the bolt, well, it's sunk down to the bottom. That's because gravity pulls it down, right? The honey is the most dense liquid, so it's at the bottom because gravity's pulling on it. Whereas the lamp oil and the ping pong ball are the lightest of the materials that are shown in this column. They have the lowest density, and so they have floated up to the top. So if you have liquids like this, they will separate out based on how dense they are, with the heavy stuff getting pulled more by gravity and the light stuff floating on top of that. Now, the Earth's layers are actually separated in much the same way. So as we know, we have the crust on the outside. We have the upper mantle, lower mantle, which we often just refer to as the mantle, the outer core, and the inner core. And yesterday we did that graphing assignment where we saw that as you go deeper in the Earth, it gets hotter and it gets more dense. So the most dense material is in the inner core there. It's actually made of solid iron, a very heavy metal. The outer core is made up of some liquid iron and some nickel, so some other heavy metals, and then it actually gets lighter and lighter until you get to the crust. Now, when you pick up a rock on the crust, you probably don't think, oh, this is so light. But compared to the iron and stuff in the core, those rocks are actually pretty light compared to iron. Well, how did it get to be separated out like this? Well, it works a lot the same way as our column. But remember that gravity doesn't actually just pull down. Since the Earth is round, gravity is actually pulling to the middle of the Earth. And so all the heavy stuff gets pulled to the middle, the lighter stuff on top of that, and the lighter stuff on top of that, just like this column. It's just that it's all in 3 dimensions, right? It's all in a circle. So the middle is where gravity's pulling to, so the heavy stuff ends up there. But the Earth wasn't always like it is now. If you look at those layers right now, actually a lot of this stuff in here is solid. A lot of the mantle is solid, the inner core is solid, and you can't have solids really passing through each other, right? So when the Earth first formed, as we mentioned in class, it was actually a big ball of lava. This was because there were big asteroids hitting each other, and the friction from those impacts was created so much heat. If you rub your hands together, that friction creates heat. Well, those asteroids would hit, they would create so much heat that it would melt them. And then more asteroids would hit them. Now, as they got bigger, they got more gravity, and so they started pulling more and more of those asteroids into them until it grew into this giant ball of magma, which is what the Earth started as. Now, while it was liquid all the way through, because it was so hot, or at least mostly all the way through, it was able to separate out by layer just like this. And all the heavy material, at least most of the heavy material, sank down towards the middle. The less dense stuff on top of that, the less dense stuff on top of that, all the way up to the crust. And again, the rocks on the crust are relatively light. They're kind of the lightweight material of the Earth. This doesn't just extend through the layers. of the rock and the metal, with the inner core being the most dense and the crust being the least dense. It actually extends all the way up through the atmosphere. Because what's on top of the rock in a lot of places? Well, in a lot of places around the world, it's covered by water, except for where the land kind of peaks up out of the water. But most of the land, most of the rock of the crust is covered by the oceans. Well, what's more dense, rock or water? Well, the rock is, right? And so it goes inner core, outer core, mantle, crust, water on top of that. And then what's above the oceans and the land? The atmosphere, the air. What is more dense? Water or air? Well, the water is more dense and the air is on top of that. So actually this separation by density extends all the way up from the inner core up through the top of the atmosphere. The lightest stuff being the gases that make up our air. The whole Earth is separated by density. So I need you to please make a bullet point in your notes. Your title of this section is Density of the Earth's Layers. Please make that your title. Pause the video if you need to, or just look at the slides afterwards. Please do a bullet point that says this. As you go deeper into the Earth, the density increases. It gets more and more dense. So make that as a subpoint. And as we know, the temperature increases as well. It gets hotter and hotter as you go towards the middle of the Earth. Pause the video here if you need to. Get this written down. Or look at the slides later. Then I also need you to please write this. So skip a line. Come back to your pink line in your notes. Earth layers from least to most dense. And then underneath that, please put atmosphere as the top layer. It's the least dense, the air, then the oceans, then the crust, mantle, outer core, inner core. That's how the layers break down. Now, really what happened when the Earth was forming, there was all this hydrogen and oxygen and all these gases that were in the rock, right? They were just atoms that were bound into molecules. When it melted, it released the water vapor. And so you had this ball of molten lava. It was surrounded by all this water vapor and other gases that were light and sifted up to the top. As it cooled eventually, that water vapor turned into clouds. It started raining and covering the Earth in the oceans, filled it up with all this water. And then all the air was separated out of that. So it separated again in these early stages. And today, like I said, we have the water and the air above the rock. It's all separated out by density. So make sure you get this in your notes as well. Pretty simple material. Just know that it goes from least dense to most dense. All right, after this video, I would like you to please watch the Bill Nye video that I posted about volcanoes. Please pay attention to that. And that is all for today. Have a good weekend, and I will see you guys in class on Monday.